Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Um, in this session, we are going to talk about sequences and series, but geometric ones, not arithmetic ones like last time. So, what is a geometric sequence? A geometric sequence consists of a bunch of numbers that are related in this manner. The first one, if we call it A, the first term, then the next one would be A times a common ratio called R. R for ratio, like D for difference. So if it's a difference, it's the same amount I add or subtract, it's an arithmetic sequence. If I multiply or divide, um, it becomes a geometric sequence. AR square, blah, blah, blah. And the nth term would be A times R to the n minus 1. Why minus 1? Again, same concept as the arithmetic sequence. Remember, the first one is A. I can call it A times R to the 0th power. R to the 0th power is 1, so you get A. Or A times R to the first power. So the second term is multiplied by R to the first. The third by R to the second. The nth is R to the n minus first. Okay, so that is called a geometric sequence. Okay, so how do I find the series? How do I add them up if I have n terms? Geometric series. Well, like I did, remember when I give you four numbers and I added them in my head and I said, oh, I know how to do it. And then what if I want to add the first 200 terms? I cannot keep adding them. So we had to develop equations. Same exact thing. Let's develop it together. Yeah, I want you to help me. I'm going to say Sn, meaning n terms. If I want to add n terms, it would be A plus AR plus AR square plus ARn to the negative 1. Then I'm going to factor out the A. So it becomes A times 1 plus R square. Does it ring a bell? No? I would be so sad if you say no. Because I showed you that if I am expanding, we did it with x. So let me write down here. X to the n minus 1. Remember how we did it? We said it's x minus 1 times x to the n minus 1 plus x to the n minus 2 plus x squared plus x plus 1. If n is 2, everybody knows how to factor x squared minus 1. It's x minus 1 times x plus 1, where n here is 2. So x to the first plus x to the 0th, and of course we don't have anything else. They are the last two here. X cubed minus 1 is x minus 1 times x squared plus x plus 1, and so on and so forth. So easy. Oh, I see this here, but instead of x, I have r, and instead of the square starting first and ending with 1, I start with 1 and end with x to the n minus 1. So if I rearrange them, I can say this equals, I divide the left-hand side by x minus 1, equals a. In economics, we do it backwards, and I will tell you why. It doesn't make any difference. Instead of saying x to the n minus 1, or this is r, I'm going to say 1 minus r to the n, and I divide by 1 minus r. Notice it's the same thing. If I multiply the left-hand side by negative 1, this becomes 1 minus x to the n, and this becomes 1 minus x. Same thing. And this is the equation that you don't need to memorize. In fact, I can derive it in 5 seconds. 1 minus r to the n over 1. Remember when I told you, but what I told you, it was x to the n minus 1. And I said, I always, when I was a kid, I thought of x as 10. Why 10 again? For the zillionth time, I'm not bragging, I'm just telling you something happened and I was lucky it was correct. So, for example, if I had x to the fifth minus 1 over x minus 1, I said, okay, if x is 10, this is 100,000. So when I subtract 1, it becomes 99,999. And x minus 1 would be 9. 10 minus 1 is 9. And when I divide this, it's so easy. 1, 1, 1, 1, 1. This is 1. This is x because x is 10. This is x squared. This is x cubed. And this is x to the 4. So it really doesn't take long to see it. Do x squared minus 1 over x minus 1 and you see it. So this helps me solve for the series, where r here is a multiplier. So I'm going to take this element and divide it by that, I get r. A word of caution, I will talk about it in a second. In some cases, if r is less than 1, if r is less than 1, I can find S infinity. What? Yeah, S infinity, meaning I can have infinite numbers. How? Here is A, 1 minus. If r is less than 1 and you raise it to a very large number, so let's say r is even 0.9, it doesn't have to be very small, just less than 1. And I raise it to the power of, say, 10,000. This is 10,000. See, I get 0. So this term disappears and I get 1. So basically it's A, which is the first term, divided by 1 minus R. This is extremely important when we do infinite series that you may or may not find in your Regents exam, but you may find it in many advanced courses of math or engineering or science, and you would recognize it and solve infinite terms in no time. Let me give you an example. Suppose I have a sequence that starts with 1, 6, then I divide by 1/2. So A is 1/6 and R is 1/2. So this would be 1/12, 1/24, blah, 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 till infinity. What is the sum of this series? The value of this series S infinity equals 1/6 divided by 1 minus 1/2. Why 1/2? Because R here is 1/2. It's this term divided by that term. 1/6 divided by 1/2, because 1 minus 1/2 is 1/2. When you divide by a fraction, you multiply by its reciprocal. So it's 1/6 times 2, it's 1/3, or 0.3 repeating. Okay? Let's check it out. Of course, I cannot go to infinity, but what I'm going to say is, what if I have 6 and I invert it, and then 12 and I invert it, and then 24, and then 48, and then 96, and then 192, and then 384, and then 768, and inverse plus, and then 1536, and then 3072. I think it's enough. Okay, so we added a few terms. Look at the result. 0.333 already. Right? So again, that becomes a special case here. So I have like 17 problems in this worksheet. Of course, I cannot do all of these. We don't have time. So let's think we do, for example, the odd numbers. Okay. First, it says beginning July 2019, Michelle deposited 250 into an account that yields 0.15% each month. She continued to make 250 every time, every month. Okay, so this is not once. Be careful. Into this account on the first of each month for 3 years. Which expression would give, say, the money after she deposited the last one on June 1st, 2022? Okay. So A here, which is a repeating payment every month, is $250. Here, what I wanted to say, two things. The first thing is, unfortunately, we call the interest R, but we use R as the ratio. So what's the problem? These two R's are not the same. What? I prefer to call in the interest I. So I don't confuse the I with the R. And I will explain it to you in a second. First of all, it's 0.15%. So I equals point. And then because there is a percent, I take away the percent because the percent is like you multiplied by 100. So if I take it away, I have to divide by 100. So it becomes 0, 0. I add two zeros before whatever number I have. 15% per month. Why? Because she's depositing the money every month. I cannot use 3 as years and the deposit per month, they don't match, right? So I have to divide the annual, uh, I have to divide, I'm sorry, I have to multiply the years. N here is 3 times 12 or 36 months. Notice that this is not the R I'm going to use because the R I'm going to use is 1 plus that, is how much every month the value compared to the previous month. So in a month, I would, if I multiply this by that, it will give me just the interest. So in other words, I deposit 250. They make some dollars. Let's say they make $2. So the next month, I will have 252. So when I divide 252 by 250, I get R would be 1.0015. Because when I multiply 250 by that, 250 times 1 gives me the amount I deposited. 250 times the I will give me the extra interest I get. So please don't use R as 0.0015. R is 1.0015. I had to spend time on this because I don't want you to get it wrong. So after 3 years, my S after 36 months would be the original amount deposited times 1 minus 1.0015 to the 36 power over 1 minus 1.0015. Notice if I switch them, it's the same thing. It's just the way they prefer to show it. But if I say 1.0015 to the 36 minus 1 over 0.0015, after I subtract 1, you will get the same result. They don't want the result. They want to see which one of those is the correct. And definitely it's number 4. 250 times 1 minus that to the 36 over that. I just spent time here to make sure you get it. And then after that, let's do number 3. Jasmine decides to put $100 in a saving account each month. So A is $100. It's the same problem almost. Oh, let's see. The account pays 3% annual. Oh, that's the opposite. She puts the money every month, but I here is 3%, 0.03. Notice you divide by 100 per year. But it's compounded monthly, meaning the interest is added every month. But every month, meaning it's 0.0003. I'm sorry, 0.03 over 12 per month, meaning it's 0.0025 per month. Again, you can divide it on a calculator. So my R is 1.0025, not this. So S, again, how in 1 year, after 1 year, so S12, N is 12, because it's only 1 year and deposit the money. So S12 would be 100 times 1 minus 1.0025 to the 12th over 1 minus 1.0025. Which one is that? 2, right? 100, this over that. Let's move to number 5. A company fired several employees in order to save money. The amount of money the company saves per year is given below. So number 5, they give me A as $59,000. Okay? And then they give me, I have to divide one by any year by the previous one to get the R, right? And this will give me R right away. I don't have to add one like I did here, because that was the interest, but this is the whole amount. Meaning I can divide 64,900 over 59,000. And I get 1.1. So R equals 1.1. N equals 5. Very easy. So now S5, in 5 years, they saved 59,000 times 1 minus 1.1 to the 5th over 1 minus 1.1. I can switch them. Oh, I thought they want us to calculate that. So that's number 1. You see here, they used the extra amount, which is like I, like you use this instead of that. No, that is number 1. That's exactly what we have. And that's the end of this page. Let's move to the next page and look at number 7. What is number 7? What's the sum of the first 20 terms? So n is 20. And the series is -2, meaning A is -2. 6, -18. They are adding them. I'm just writing the sequence. I divide this by that or this by that. I get R equals -3. Wow. So how do we do that? Same thing. S20 equals A, which is -2, times 1 minus R is -3. So -3 to the 20th power, which is a huge value, divided by 1 minus -3. So really, this is -1/2 because it's -2 over 4. It doesn't matter. We can use the calculator because they want us to find which one of the, of course, it won't be the first two. It's impossible. So one of these two. -2 times 1 minus, open parentheses, -3 to the 20th power. It doesn't matter negative or positive because -1 to the 20th power is positive, divided by 1 minus -3, which is 4. And that basically is the answer. 174339220, it's number 3. Just easy. Number 9. The first term of a geometric sequence is 8. A is 8. And the fourth AR cubed is 216. Do you see that? It's the fourth. So R to the n minus 1. Okay. What is the sum of the first 12 terms of this series? As if we don't know how to do it, right? N is 12. So first of all, we need to find R. I know that AR cubed over A equals 216 over 8. This guy is R cubed. And then I'm going to take uh, the cube root of both sides. Notice I don't say plus or minus because the cube root follows the sign. If this is positive, you get positive. If this is negative, you get negative. So R equals the cube root of 216 is 6, the cube root of 8 is 2, or I could have divided 216 by 8 and I would have gotten what? 27, and the cube root of 27 is 3, or use the calculator. So anyways, R is 3. So now the first 12 terms would be 8, which is the first, times. I prefer when it's greater than 1, really, in all of these, to do it backwards. It's not wrong. You don't have to do it my way. You can keep it 1 minus R to the n minus 1 to the R to the n minus 1 minus R. But I would prefer to do it backwards. I have to say 3 to the 12th power minus 1 over 3 minus 1. This over that is 4. So I'm going to say 4 times 3 to the 12th minus 1. So I get 2125760. That's number 3. As I said, whether you say R to the n minus 1 over R minus 1 or 1 minus R to the n over 1 minus R, you get the same result, of course. This is pure algebra. Number 11, J is training for a bike race over 15 weeks, so n is 15. At the end of the first week, he has ridden 10 miles, so A is 10. And he's planning to increase his weekly distance by 9% each week. 9% meaning 0.09. You have to add 1 to that. Why? Because the next month, notice if you say 0.9, then the next month he would be doing only 0.9 miles. And then the following month would be making 0.81 mile, which doesn't make sense. But it's 10 times that, so you get 10.9. You see? And then you keep multiplying by 1.09, not by 0.09. Again, same as the interest. We are not looking at the interest, we are looking at the whole amount in the account. This is R. I think we have everything, right? Yeah. Approximately how many miles total will he have ridden from the beginning of the training till the end of the 15th week? Okay, so the amount traveled, or S15, again, we are doing the same stuff over and over again, so I don't see why. Again, last time I did R to the n, so let's do it this time the other way around. To the 15 over 1 minus 1.09 or negative 0.09. Okay, so here is 10. I open the parentheses, 1 minus 1.09 raised to the 15th power divided by, I could have written negative 0.09, but let's write it exactly as it is in the equation. I get 293 miles, 0.609. 293, it's the last one. Wow, I used 3 decimals and they have 3 decimals, just by chance. Okay, let's look at number 13. We don't have enough space. I'll try to cram it here. Number 13, it says, Miranda joins a gym and pays an annual membership of $400. Annual, so every year. So that's A, is $400. Due to rising costs, the gym operator has told her the membership would increase by 8%. Increase by 8%. So it was 1 for every dollar, R becomes 1.08. That's how you add 8%. Okay? Don't say 0.08, please. I've seen even when I was teaching engineering economics, and that was usually either some sophomore take it, but commonly is juniors, sometimes seniors in college were taking it, and they had hard time to use the interest heading the one. And we had to spend time, but once they get it, of course. So I don't want you to reach that stage. I want you to see why it makes sense to use 8% increase. If it's 8% decrease, then R would have been 0.92. I would subtract 0.08 from 1 if it was decreasing, because you can have that. Like I showed you the infinite uh, infinite series, 1/6, 1/12, 1/24. It's getting smaller and smaller. Okay, but all of these, of course, are increasing. How much will Miranda have paid in total to the nearest dollar if she is a member for 6 years? Guys, it's the same all over again. I don't like that. Okay, so S6 is 400 times 1 minus 1.08 to the 6th power over 1 minus 108 to the nearest dollar. 400. Again, I'm wasting your time, I know. 1 minus 1.08 to the 6th power divided by 1 minus 1.08. And I get to the nearest power is $2,934. 2934 is number 13. Still have two more. Okay, let me try to find the space here and say, okay, number 15. A research assistant receives a first-year salary of $90,000. And 2% annual raise. So R is 1 plus 2%, 1.02. Okay, not 0.02. I keep repeating myself. You get bored, but it's so important. Throughout the first 10 years of employment, in total, how much money will be earned over the first 10 years to the nearest dollars? Again, S10 equals 90,000 times 1 minus 1.02 to the 10th over 1 minus 1.02. Notice that only this is raised to the 10th, not the whole thing. Be careful with these small mistakes. Okay, because sometimes I don't know if they did. No, I don't think so, but they may show you something that one of the answers would be if you made the error by saying 1 minus 1.02, everything raised to the 10th power. And that would be a very small number, probably. I don't know if it would be here. 90,000 times 1 minus 1.02 to the 10th over 1 minus 1.02. How many times did we do that? So to the nearest dollar, it would be 985,475. Yeah, that's number 4, 985,475. The last one, bear with me. Did I drop this pen? Okay. That's a pencil. Number 17, the last one we have, given the geometric series 300 plus 360 plus 432 plus blah, 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 write a geometric series Sn for the sum of the first n terms. Use the formula to find the sum of the first 10. Okay, so A is 300. If I divide 36 or 36 by 3, I get 1.2, right? So R is 1.2. 1 minus 1.2 to the n over 1 minus 1.2. Again, here's how you do it. Divide 360 by 300. You get 1.2. Or divide 432 by 360, meaning the third over the second. You should get the same result. And so on. So you just do it twice to make sure it's geometric, not arithmetic. Because if they tell you 300 plus 360 plus 420 plus 480, they keep adding six. Here we know we are doing geometric, but in the regions you wouldn't know. Is it geometric or is it arithmetic? So you check that first. Is it the same difference or the same ratio? It's extremely important to do that. Now I'm going to substitute n as 10. Use my calculator, 300, open parentheses, 1 minus 1.2 to the 10th power, divided by negative 0.2, or just to write it exactly as we have it. And that is 7,787 point, the nearest tenth, so 0.6. And that concludes the topic of sequences and series, arithmetic and geometric. We still have a lot. Um, I haven't yet posted the first like session of this course. I had like back exams, but because I was finishing, I think tomorrow I will finish posting the Algebra 1 Regents. So I will go back and start to post like 2 lectures a day so we can finish the whole course. I just noticed we didn't do conic sections, so circles, ellipses, parabolas, and hyperbolas. So I will start that the next session, and that leaves us still with, oh my God, graphing trig functions along with transformations and probability and statistics. So we still have 4 main topics. I thought we were closer than that, and then when I checked, I noticed that. So anyway, again, thank you very much for watching. Sorry if it was a little longer than I was planning. If you have any questions, any comments, please don't hesitate. Be my guest and send me comments. I like to read your comments. I will try to respond to you as soon as I can. If you don't, then best of luck. Have a great day. See you soon. Bye.